Dear students, welcome to s.mathguru classes. So our main discussion is eigenvalues and eigenvectors. So we solve some problems, and these eigenvalues and eigenvectors are most important for any engineering courses. It may be in civil engineering, mechanical, electrical, electronics. So these are most important, and BHC major also these are most important. So last class we solved some problems, and again you consider another problem. Find the eigenvalues and eigenvectors of matrix A equal to 4 2 minus 2 minus 5 3 2 minus 2 4 1. So we consider this solution. The characteristic equation is determinant A minus lambda I equal to 0. So determinant A minus lambda is means 4 minus lambda 2 minus 2 minus 5 3 minus lambda 2 minus 2 4 1 minus lambda this equal to 0. This is the characteristic equation. Now we expand this 4 minus lambda, this cancel, we get this into this. So this will be 3 minus lambda 1 minus lambda minus 8 minus 2. First you consider this, that minus 2, this cancel, this into this into this, minus 5 into 1 minus lambda and this into this 4. So minus 5 into this minus this into this is 4 plus minus 2, then this is cancel, this into this, minus 20 plus 2, 3 minus lambda equal to 0. So I get this one. So this implies 4 minus lambda, this is 3 minus 3 lambda minus lambda plus lambda square minus 8 minus 2 minus 5 plus 5 lambda plus 4 minus 2 minus 20 plus 6 minus 2 lambda equal to 0. So we get this 4 minus lambda, this is lambda square minus 4 lambda minus 5, 3 minus 8 minus 5, and minus 2, 5 lambda minus 1 minus 2, this is minus 2 lambda minus 14, this equal to 0. So this implies 4 minus lambda, we multiplying this by 4 minus lambda, multiplying all of these by 4, 4 lambda square minus 16 lambda minus 20 minus lambda cube plus 4 lambda square plus 5 lambda minus lambda cube plus 4 lambda square minus 5 plus 5 lambda, and this is 10 lambda plus 2. This is 4 lambda plus 28, this equal to 0. We get this one, and this implies minus lambda cube this, and lambda square this and this, 8 lambda square plus 8 lambda square minus 16 lambda plus 5 lambda, this is minus 11 lambda minus 21 lambda plus 4 lambda, so minus 17 lambda, and minus 20 plus 28, this is 8. this equal to 0. Multiplying both sides by minus sign. So this implies we get lambda cube minus 8 lambda square plus 17 lambda minus 8 equal to 0. We get this. So we multiplying by minus sign, we get this. But this is cubic equation. This is difficult to solve. So first we putting factor theorem using. The last number is minus 8. Minus 8 we can write minus 1 into 8, 1 into minus 8, or minus 2 into 4, 2 into minus 4, just like this. We putting this value one by one in the here where we get 0. So we consider f lambda equal to, let f lambda equal to lambda cube 8 lambda square 17 lambda minus 8. Putting lambda equal to 1, then 1 cube 8 into 1 square 17 into 1 minus 8. 1 minus 8 plus 17 minus 8. This is so we get. So this one actually this one simple mistake. This is 28 to 30 minus 20. This is 10. This will be 10. 10 we get, and this is 10. We get 10. 10. This is 10. Then this one 18 minus 18. This is 0. If it is 0, by putting lambda equal to 1, we get answer 0. Here I have mistake this one to drop out. If it is 0, then we can write lambda minus 1 is a factor of f lambda. F lambda means this. That means if we divide this one by lambda minus 1, we get remainder 0. Next we divide this one, lambda minus 1. This one divide by lambda minus 1, lambda cube minus 8 lambda square plus 17 lambda minus 10. So putting lambda square here, this and this lambda cube, this and this minus lambda square. This is minus 7 lambda square plus 17 lambda minus 10. And minus 7 lambda you consider, this and this minus 7 lambda square plus 7 lambda. This is 10 lambda minus 10. And putting 10 here, then 10 lambda minus 10, we get remainder 0. So we get this. So therefore lambda cube minus 8 lambda square plus 17 lambda minus 10 equal to 0, and this we multiplying this and this, that means dividend equal to divisor into quotient plus remainder. So if we multiplying lambda minus 1, lambda square minus 7 lambda plus 10 equal to 0. So we get this, and if we factorize this one, lambda minus 1 remains same, and this is lambda square minus 5 lambda minus 2 lambda plus 10 equal to 0. Lambda minus 1, lambda common, lambda minus 5 minus 2 common, lambda minus 5 equal to 0. Lambda minus 1, lambda minus 5, lambda minus 2 equal to 0. So lambda equal to 1, lambda equal to 5, lambda equal to 2 we get. These are the eigenvalues 1, 2 and 5. These are the eigenvalues. Next you have to find eigenvectors. So eigenvectors you have to find in this way: a minus lambda I x equal to 0. So a minus lambda I, we know this value. This is a minus lambda I. 4 minus lambda 2 minus 2 minus 5, 3 minus lambda 2 minus 2, 4, 1 minus lambda. Just I have written this, and x means we consider x, y, z, and right hand side is 0, 0, 0. We get this one. And if we multiplying this, we get 4 minus lambda 4 minus lambda x plus 2y minus 2z equal to 0. This into this, this into this, this into this. Minus 5x 3 minus lambda y plus 2z equal to 0. Minus twice x plus 4y 1 minus lambda z equal to 0. So we consider this whole is 1 we consider. So this one we consider 1. Now case 1. Case 1, we putting lambda equal to, let lambda equal to 1. So here I putting lambda 1. 1 implies 4 minus 1 x 2y minus 2z equal to 0 minus 5x 3 minus 1 y plus 2z equal to 0 minus twice x plus 4y 1 minus 1 z equal to 0. This can be written as 4 minus 1 3x plus 2y minus 2z equal to 0. 3x 2y minus 2z equal to 0 minus 5x plus 2y plus 2z 0 minus twice x plus 4y plus 0z equal to 0. This is number we consider 2, this is 3, and this one 4 we consider. 2, 3, 4. Now solving 2 and 3, we get, solving 2 and 3 we get this 2, taking x, then this cancel, we get this. 2, 2, minus 2, 2. Next y, this one cancelled, minus 2, 2, then 3, minus 5. And z, this one cancelled, this. 3 minus 5, 2, 2. We get this. So x, then this one cancelled, 2, 2, minus 2, 2. Y, this is cancelled, then this. Yeah. And z, this one cancelled, this. So this implies x by, this is 4 plus 4, this into this. Y by 10 minus 6, z by 6 plus 10. X by 8, y by 4, z by 16. dividing by 4, x by 2, y by 1, z by 4. This equal to k1 say. So this implies x equal to 2k1, y equal to 1k1, z equal to 4k1. Therefore, x, y, z 2k1, 1k1, 4k1, and k1 is common. This is 2, 1, 4. First eigenvector we get. This is the first eigenvector. Next, putting lambda equal to 2. Case 2, let lambda equal to 2. 1 implies, we putting this variance 1, 4 minus 2x plus 2y minus 2z equal to 0, minus 5x, 3 minus 2y plus 2z equal to 0, minus twice x plus 4y, 1 minus 2z equal to 0. Just putting lambda equal to 2. And this implies we get 2x plus 2y minus 2z equal to 0, minus 5x plus y plus 2z equal to 0, and minus twice x plus 4y minus z equal to 0. So 2x, 2y minus 2z, 5x, 1y, 2z, 2x, 4y minus z equal to 0. Now I consider this is 5, this one 6, this is 7. Solving 5 and 6, we get x 5. This one cancel. This. 2, 1 minus 2, 2. Next y. This one cancel. Minus 2, 2. 2 minus 5. Z. This one cancel. 2 minus 5. 2, 1. This one. X. This one cancel. 2, 1 minus 2, 2. Y. So we get this one. Next, this is x by 4 plus 2. This into this minus this into this. Y by 10 minus 4. Z by 2 plus 10. And this will be x by 6, y by 6, z by 12. Dividing by 6, then we get x by 1, y by 1, z by 2. This equal to k2. Say. This implies x equal to 1k2, y equal to 1k2, z equal to 2k2. Therefore, x, y, z this equal to 1k2, 1k2, 2k2. And k2 is common, we get 1, 1, 2. Second eigenvalue we get 1, 1, 2. This one. Next, case 3. In case 3, let lambda equal to 5. Case 3, we putting lambda equal to 5. So lambda equal to 5, putting in equation number 1. 4 minus 1 implies 4 minus 5 x plus 2y minus 2z equal to 0. Minus 5x plus 3 minus 5y plus 2z equal to 0. Minus twice x plus 4y plus 1 minus 5z equal to 0. Just putting lambda equal to 5. Here 5, here 5, here 5. So this implies we get this is minus x plus 2y minus 2z equal to 0. Minus 5x minus 2y plus 2z equal to 0. Minus twice x plus 4y minus 4z equal to 0. Minus x, 2y minus 2z minus 5x minus 2y, 2z minus 2x, 4y. This is number we consider 8, this one 9, this is 10. Now solving 8 and 9. We solve equation number 8 and 9. We get x, then this x cancel, 2 minus 2 minus 2, 2. So we get 2 minus 2 minus 2, 2. Next we consider y. Y means this one cancel, minus 2, 2, minus 1, 5. Minus 1, minus 5. Minus 2, 2, minus 1, minus 5. And z, then this one cancel. We get minus 1, minus 5, minus 1, minus 5, 2 minus 2. 2 minus 2. So you just, we always start from right. X, y, z, again x. When consider x, then y, z. Like this. Y, then z, x. This. Z, then x, y. And this implies x by 4 minus 4, y by 10 minus plus 2, z by 2 plus 10. This is x by 0, y by 12, z by 12. And this is dividing by 12, 0, y by 1, z by 1, this is k3. This implies x equal to 0 k3, y equal to 1 k3, z equal to 1 k3. Therefore, x, y, z 0 k3, 1 k3, 1 k3, and k3 common, we get 0, 1, 1. This is another eigenvectors. The eigenvectors are first eigenvector this, second eigenvector this, and third eigenvector this. Now all of this we write together. Therefore, we write all the results together. Therefore, the required eigenvalues are 1, 2, 5, and eigenvectors are first eigenvector k1 2 1 4, next k2 1 1 2, next k3 0 1 1. So these are the eigenvectors. These are eigenvectors 2 1 4, 1 1 2, and 0 1 1. And eigenvalues are 1 2 5. This is the complete solution. These are most important. I hope you are all enjoying with this type of problem. If you are all enjoying, then please share this video to other engineering friends also. And these are most important. This type of problem will come, whether this will come or not, but this type of problem will come in your exam. So thank you for watching the video.